Yo! Welcome back to another episode of the Saikyo cross-platform app development show series thing. Let's just dive straight into it. So last time, what do? We went through and we talked about Unity builds, and I gave my kind of spiel about why just hash including things is appropriate for a C and C++ style build. And we also looked at making our window first pop up, but also be closable. Although it looks like I broke it. What did I do? What's happening? I'm a little confused right now. Oh, and then it just worked. Wait, let me try that again. I don't think that was an us problem. I think that might have been. Oh no, it is. That's strange. Oh, I see. If it's not directly over the X, then it won't click. So if I click just below the X, okay, that worked. So we must be off a little bit, which is a little strange. I'm not going to lie. Or it could be that the mouse. Okay, so it's a little fidgety. To be honest, in my testing with AppKit, I've never actually seen that be a problem. So it could actually, you know what it could actually be? When I click down, but I move the mouse up on the up click, that might be what's happening. But if I just leave it inside, then it's okay. Which would make sense. Which is, to be honest, that's completely okay. And the reason why that's okay is because eventually we don't even want to be passing through. I don't think we do pass it through here anyway. No, we manually exit out of the loop. But for other buttons, for example, minimize and things like this, and also when this is clicked, we'll want to run other actions as well. For example, save the current state of the program. So when the user loads it back up, then it will just jump back to where it previously was. So this might look a little bit like a bug right now, but I think we'll leave it. And the reason why we'll leave it, does it do the animation? It doesn't. So there's also, like, when you click a button, it's meant to look like it depresses a little bit. So it's like feedback. But for us, this isn't doing anything. It's just staying the same. And we know when we release it, then it closes. So there is there's definitely space to improve this, which we will improve it. But that's not going to be the focus for today. As you'll see, there's going to be a lot of these kind of little finicky platform things that we'll have to deal with as we put this app onto the various platforms. And we're just using AppKit right now as a base, which is kind of what I wanted to talk about today, actually. I wanted to talk about how the architecture of this app is going to look like and kind of my inspiration and motivation behind doing that. So I should be able to jump into, was it sketch.io? Was the program we used last time? Or it was named similar. Was it Sketchpad? Good enough. Okay, so let me just draw a few boxes here. It's very difficult to draw with a trackpad. Let me see if I can actually use my other mouse. This might be a bit easier. Slightly easier. So we have this box, and we'll call this a platform. Plat. And on this side, we'll have our app. So the platform, this would be things like, iOS or Mac OS or Windows. This is not the device, this is the operating system that we're running on top of. Device differences will be smoothed out by the operating system doing things for us. What we need to care about is how to tell the operating system to do things on our behalf. And that's where we need to take care of the differences between the operating systems. So there's kind of two philosophies when it comes to doing cross-platform apps. The first philosophy is that the app is kind of the main driver. Can I change color? How do I change color? Not fill, I want... maybe it is fill, actually. Let's do purple, maybe. That is not at all what I want. Okay, you know what? We'll just go back to being what this was before. Can I even do that? Maybe not. Just this. It's very strange. Select? Nope. About just nothing. Maybe if I reload this, actually it'll fix. Not quite. How can I disable fill? Can I just like disable this? If I can disable it, then it won't do this strange thing where it begins to draw a polygon. Like this. Okay, there we go. So there's two main ways people think about this. One is that the app is the main driver. So if the app is the main driver, you know what? I'm going to put this in the text box. Just any text. Yeah. So when the app is the main driver, what this would mean is that the app is, there's going to be an entry point from the platform, whether it's a main function or like a callback function that the operating system calls that we enter the app from. But then from there, the app takes control of everything. And what it will do is it will, maybe one less space, it will wrap the OS into a cross-platform API. And you see this kind of thing with, for example, the C standard library, right? Like if you have a file, I think they spell it all caps, don't they? So this file pointer, this file thing is an abstract data type. It's an opaque pointer. And what this does is that it wraps the underlying operating system's file descriptor on POSIX systems, or it will wrap a void pointer, a handle on Windows systems. And whatever other exotic interface there is, the underlying file system file wraps that. Mm. And it's not just with file. Usually you'll see in other, for example, in Python, there's the sockets API, which wraps the operating system's underlying sockets. And then there's also, I mean, there's numerous examples in LLVM. They have a whole like sys like sub package, and inside of sys, if I can just jump quickly to it, yeah, well, not quite that. LLVM sys, yes. So they would wrap things inside of here like the clocks, and they also wrap file IO, obviously since it's LLVM. I think they will also wrap things like performance counters and operating system level stuff. And in this paradigm, the app is the view of the world, and any services that it needs from the operating system, it will wrap in some sort of cross-platform way. Now, personally, I don't like doing this. Like having the app be the main driver is not necessarily the best way to do that. And the reason for that is because if you try to wrap system services so that the app can use it, implicitly what you're saying is that every operating system that you want this thing to exist on must have that service. Otherwise, you have to do hacky things like you have the definition of the function, but it either throws in an exception or crashes or does nothing. And to me, that seems stupid, to be honest. It seems like you're trying to put a band-aid over a solution that wasn't a proper fit to begin with. So I don't like the app as the main driver is not, in my opinion, the best thing to do for this kind of app. And this kind of app is honestly, it's a bootlegged game. All of these phone level applications, enterprise applications are just a bootlegged game, right? What does a game do? It takes in user input, it updates the state of the world, it renders to the screen, and maybe in the background it does network requests and things like this. Like an app is basically just a game without the intense graphics. So we should follow what game people do. And what game people do is this. What they do is the platform layer is the main driver. And what it does is it uses the app for services. So what that means is that the entry point will still be from the app. So maybe here we enter with main. And from there, the platform layer will set things up. It will set up memory. It'll set up memory. It'll set up, network, the network infrastructure or things like this. Network. Again, I cannot stress to you how difficult it is to write with a trackpad. The platform layer will also take care of assets. Oops, that's too small. Assets are things like pictures, icons, strings, like the UI. And very critically, for if we want to have this app be truly cross-platform, the main kind of thing that it does, obviously, as a platform layer, is that it deals with OS integration. And this is in the enterprise space, this is the most important thing above all else. And the reason for that is because, any platform that supports games will let you do things like memory management through the virtual memory system. It'll let you do network requests through usually the underlying operating system socket layer. Asset loading is usually included as well. That's fine. But what games generally don't care about are things that users of an app will care about. For example, accessibility. This is very annoying. Let's write this. For example, accessibility. Very important, especially if you're going to write for applications on the web, applications for iOS, applications for Android. Having accessibility is important for user-based trust, right? You want people who may not be able to, for example, see color properly, or unfortunately, you're blind, or maybe they have hearing difficulties. Like, if they can use your app, that's just one more person that you're inviting into your world, and we want to be able to support those kinds of people. Other things is you want to, for example, on macOS, if I look up, we have the taskbar, whatever these things are, the icons in the activity bar, where you can look at the status of things and get notifications and things like this. So that's something that generally games don't care about as much. They do naturally, probably since the mobile phone revolution, but historically, I don't think they did as much. Also, we care about things, accessibility notifications, OS integration. This is honestly mainly for phones, I would say. Well, I guess it's not true. For example, if we go back to running our window, if you look closely at my dock here, there is no like app icon for this window. As far as macOS is concerned, this window is a child of C Lion, which is not good. We want this to be its own separate application. And to allow for that, we need to make sure that the app will abide by the convention that the macOS operating system has set for it. So there's a whole bunch of complexity around the platform, and we don't want the app. The app can't deal with all of this in a cross-platform way. It's obviously platform specific, but by definition. So that's why having the platform layer handle that is the right thing to do. And then what the platform layer then asks the app, can I try change color this time? Maybe outline is the right thing. We'll do blue. Does that work? Hey, there we go. Instead, what the platform layer will do is it will go to the app and it will ask, it will ask questions like, what is the current UI? Given input state, that's way too small. Given the input state, maybe I can left align this, so don't worry about it. Given the input state, given the just regular program state, like the memory, expand this out. Drag it. So the platform layer will go to the app. It will ask for this. And then the app will return back to the platform what it thinks the next state of the program should be. And we'll make this, again, a text block. And in this way, this kind of platform going to the app giving back the result, and then the platform layer would go ahead and deal with rendering, deal with trafficking network requests, deal with things like this. In this way, we can very cleanly make a separation between what is platform specific. Will this go behind? It will not. But by having this separation, we are then able to take our app, which will be the majority of the code. 90% of the code will be app specific. This is where the business logic is. This is where the behavior, right? This is the behavior of the app. That will belong in our platform non-specific layer or our cross-platform part. And then by having various entry points into those services that the platform layer takes advantage of, it lets us move relatively freely between the different platforms. And this is how we're going to proceed. Now, just for historical kind of completeness, and this is going to be mainly exposition, I suppose. What solutions do people have now for this cross-platform problem? Let's take a look-see. Can you please expand the canvas? Excuse me. Hello? Okay. I guess we'll do it over here then. So we'll say cross-platform current solutions. What do people do? Well, one is that everything is a web app. This is like Electron, React Native. And this is absolutely the wrong thing to do, in my estimation. And the reason why you don't want everything to be a web app is plain and simple, things are just simply too slow. Now, I understand for an enterprise app and for, not escape velocity, but like initial startup velocity, people running things, trying to make things as quickly as possible, this seems like it would be a good idea. But the truth is that what you save at the start, you pay for it massively in multiples later on. And the reason for that is because you quickly write something, use a bunch of open source libraries to help you get up to a barely working state, release that, it gets popular, and then suddenly now, outside of your initial design, your users come flooding in. These systems, they cannot keep up. They just simply cannot keep up. Things slow down to a crawl. You end up seeing horrific things like, for example, VS Code opening Google Chrome uses many multiples of gigabytes of memory, even though it's basically just text. It's but just text, which is ridiculous. And you eventually have to do a rewrite anyway. So rather than going through two hoops, it seems like it's a smarter idea just to architect the thing correctly from the start and then scale gracefully. Anyway, that's that's things that people do, number one. The next thing people do is they duplicate code bases. And this, I think, is honestly my, I wouldn't say it's my opinion, or I don't really have any facts, but it's my kind of intuition about this, that a lot of companies, they will just go through the headache of duplicating a code base for the different platforms. I know, for example, I think VLC has a core, which is in C++, and then they have a VLC Android, VLC iOS split. But their app splits, they are not small. The platform specific layer is not small. They basically rewrite the whole UI across the different platforms, which is also patently ridiculous. We're not going to be doing that, and I'll show you how we can avoid doing that by taking care of that kind of stuff ourselves. Obviously, duplicating code bases is the most expensive thing that you do. So you don't want to be duplicating your code base because you're basically doubling your effort. It's not quite double because you do have a common core, but you are essentially duplicating your code base. So you want the platform layer to be as thin as possible, but in my experience, that's not what I've seen other code bases do. Now, the third thing that people will do is they'll kind of do what I'm talking about here, but what they'll do is they will use a third intermediate language / library. Flutter is a library, and Dart is the language that Flutter is written in. And what Flutter does, to my knowledge, is that you essentially use a single language to write the whole app in, and then the Flutter compiler will go through and convert its quote unquote platform layer into the specific. Whoops. I like how Control Z doesn't like undo the rotation. That's what you call bad user experience. Okay. What Flutter will do is it will take your app UI logic, platform specific logic, and it will I don't know if it's necessarily compiling, but it will transpile at least to the native UI interfaces for the platform. So for Android, this would be Vue. This is still very difficult. For iOS, this would be UIKit, which is the native UI widget toolkit on iOS. And if this were macOS, it would be using AppKit. And for the web, I guess this would just be the DOM API, since that is what Flutter is known for. Yeah, it would be DOM, and I think also new versions of Flutter will also take advantage of WebAssembly or WASM, like this. And this also is, in my opinion, a little strange. And the reason why I don't think using Flutter is a good idea is because Flutter, just like Android's views, just like Apple's UIKit and AppKit, and just like the web, all of this is still written from the perspective. It's not written from the perspective of a performant, lean, power efficient, time efficient, respecting the user efficient. That's not a thing. Respecting the user's time perspective. These are written purely with the express intent that they just want the code to be transpiled down so that they don't have to touch the operating system itself. It's not a way to save time so much as it is a way to hide the OS from the developer. And I mean, I suppose there is no like moral distinction about why that would be not the right thing to do, but I don't believe it is the best for the user. I think that if you're going to write software, you should be writing it from the perspective of the maximizing usability, maximizing performance to the extent that is possible without actually losing time. And also writing it with the sense of having reliability. And I just don't think that Flutter provides that level of reliability. I could be wrong, but that's what I think about that. So this is what people usually do for cross-platform solutions nowadays. And all of these, it's kind of the philosophy that undergirds these three things, which is the reason why if you download any app from any app store, it's like 100 megabytes, multiple megabytes. And you start it up and it takes like 10 seconds for it to boot up. And they don't think it's a problem. And it's just absolutely ridiculous. It's just absolutely unacceptable, in my opinion. So Saikyo is not going to be like that. We're going straight to the middle, and we're going to, um, I guess, be the counterexample to why we don't need to do this anymore. So this has been a lot of exposition. We have not written any code for today. I wanted to also start talking about how we'll start architecting the UI and what that's going to look like in kind of UI architecture philosophy as well before we start diving directly into it. But you know what? I think we'll leave that for the next episode because we're coming up on time right now. So thank you very much for watching. This has been episode 3 of the Saikyo cross-platform language learning app, where the only internet show where we'll be making a cross-platform app in C++ and explaining how we do it along the way as well. So please leave any questions that you have inside of the comment section. I will try and get to all of them. And have a great day. Take care.